All right, welcome to Algebra 2. This is 524. So, fairly short lesson here today. So we've talked about logarithms quite a bit in the past. So what I want to talk about today really is the log button on your calculator. Now you probably have a scientific one. You're going to see two buttons on most of them. One is log and one is ln. ln is a very special type of log, which I'll talk more about in a pre-calculus class. But for us, we have the log button. So I've specifically told you to not use that thus far because it doesn't do what you think it does. So we're going to try and investigate what that button does. So what I want you to do is get your scientific calculator out. And if you think back to what we did the past few times, if I had log base 3, I would get very, very nice answers by doing log base 3 of 3, log base 3 of 9, log base 3 of 27. So all of those powers of 3 gave me nice, pretty answers out of it, right? If I had log base 2, my powers of 2 gave me nice, pretty answers. So log base 2 of 2, log base 2 of 4, log base 2 of 8, log base 2 of 16, and so forth, right? So what I want you to do is try different logs. So try log 3, and I get 0.477, so it's not pretty. So it's definitely not base 3. Let's try log 4. Keep trying this until you find some values which give you nice, pretty numbers. Once you have that, try and find more, and then try and use that to say what is the base of the log that button's doing. So go ahead and pause and try that out. Okay, so what you should have found is that if you do log of 10, you get 1. If you do log of 100, we get 2. So this is telling us that our base is 10. So 10 raised to the 1 is 10, 10 raised to the 2 is 100, 10 raised to the 3 is 1,000. So 10, 100, 1,000, 10,000, and so forth are going to give you those nice, pretty numbers when you plug those in. So that log button on your calculator is log of base 10. That's called the common log. We're not really going to use that formal term quite yet, but I'll give it to you a little bit early here. So the common log is used because we have 10 fingers and 10 toes, right? So we as humans developed a counting system that's mostly based around tens. Some cultures and stuff have developed ones not based around 10, but most people have stuff based around 10 just because as humans, that's how we first kind of learned how to count. So it kind of makes the most sense for us. So it's useful for things going forward. But you might ask, well, why don't I have a button for log base 2 or log base 3 or log base 4? Well, one, we just don't want that many buttons. But primarily, it's because we don't need it. Next chapter, I'm going to show you how we can do a log of any base just by using that log base 10 button. Seems kind of weird now, but it'll make sense once we get there next chapter. So we're going to change gears a little bit. And we're going to take a look at this log base 10 and just kind of how we can transform it. So I'm actually going to skip this. And we're going to jump over to my Desmos. Make sure that's showing up. Awesome. So if I graph log of 10, sorry, log base 10 of x. So I can just type log in Desmos and it assumes it's log base 10. Whenever you see a log written with no base, it is base 10. That's called the common log because we just kind of write log. We don't always write the base for it because we don't really need to there. So if I want to do some transformations here. So all the ones we've done in the past are going to still work here for logarithms. So if I want to do a vertical shift, up 5 plus 5, down 3 minus 3, stuff like that works just fine. If I want to do a horizontal shift, that's adding and subtracting to the x, not on the outside. So if I do a minus 5, I actually go right 5. If I do a plus 4, I go left 4. So there's my vertical and horizontal shifts. Great. Again, those still work the exact same way as every function because logs are still functions. What if I want to do a vertical expansion? I want to stretch it vertically. If I do a 5, multiply it out front. Now, every value has been multiplied by 5, so it's 5 taller, or 5 lower under the axis, depending on the orientation. So we're seeing that. Awesome. What if I do 0.5? Now it's half. Now everything is half as tall. That's a vertical compression. So again, these are doing the same things as we saw with quadratics, with like cubics, with all these other functions. These rules still apply, which is why they're useful things for us to learn. And what if I want to do the horizontal expansion or contraction? I do that on the inside. So times 2, now everything is half the distance. It's being contracted in by a half horizontally. If I do 0.5, I'm now being expanded horizontally by double. And then the last types, or if you do a negative on the outside, that's a vertical flip, so it gets flipped vertically. If I do that negative on the x, I get a flip horizontally. So those, again, are the exact same rules we've been going over all year long. We're just saying, hey, yes, these still do apply to logarithms. So a general rule to kind of keep in mind, if it's happening to the x, it's going to be a horizontal change. Happening to the outside, that's a vertical change. Also, the things that happen on your x are going to be the opposite of what you would naturally think. For instance, times 2, it's being halved. If I do plus 5, it's actually going left 5, not right 5. So all those kind of inner parts are the opposite of what you would think, but just kind of keep that in mind that x's are all horizontal, outsides are always vertical. All right, let me hop back over here. So we're going to wrap up here real quick and take a look at this little part here. So if I have log base 6, we get 0.778. So like, why is that, right? Well, if I have log of 10, that gives me 1. And log of 0 gives me, and log of 1 gives me 0, right? So it has to, so any value between 1 and 10 is going to have to give me a result between 0 and 1. So it's just trying to get you to kind of see that, and just once again, just become more fluid with logarithms and such. All right, with that, that is all we have for today. So we're going to be doing 96 through 104 for our homework, and then the next assignment we have is actually the closure, because this is the end of chapter 5 for us. So we're going to be going ahead and doing 126 through 134 for our closure. And I will talk to you guys next time.